Hi everyone, this is GROUP32. In this session, I'm going to show an overall flow of our thought and works in the project. At the early stage of the project, we decided to come up with some heuristic function, because whether it's a classical planning with the cost or the MDP problem with the benefits and rewards, we need something to measure each step of our action. So first, some idea is like we can use the Euclidean distance between the corresponding position of that tile in the grid to the center. That means that if we can fill the center first, then the chances to get the tiles connected in the next step will be huge. Then fill it in the corner. And for the transition cost, we can use this. We use the remain place in this pattern line divided by the number that will be put to this pattern line. But after you use those heuristic search function and algorithm, we found that this algorithm can only perform one-step search because it cannot handle the dynamic environment. So we try to think about if we can use rewards to make this problem become MDP problem. We try some hard coding rules and find if we can use the score round function and calculate the score of each state earlier, then this method can perform pretty good. We simplify this idea and get the BFS MCTS theory. It uses the BFS idea combined with MCTS idea. But for MCTS, it will not complete the simulation part after this state. We assume that after we execute the action, the next state is the terminal state. We do an early checkout and get the reward back to the previous state. Then we do a BFS for each available action in this state. So advantage is that this transform probability is always 100%. It's always accurate. The reward is always accurate, but the limitation is that it neglects the influence of future and the influence from the opponent. Then, to overcome this problem, we try to simulating the MCTS further till we get a true terminal state. But the problem is that transition probability is really hard to get this time. And because of the large space of this game, it may cause some timeout issue for this online approach. Another trial is we add one more step of opponents, and we consider our opponent are rational. So if we choose the best move in the next state, then we calculate the gap between our score and the opponent's score. But still, it cannot overcome the future value issue. Another thinking of this problem is using a neural network to approximate the Q value. And this can be a future improvement of this project. For our group, we extracted 120 factors from the game state and make it to a 120-dimensional vectors and train this vector to measure the Q value. But it proved that it's really hard to get this neural network, this fully connected neural network converged. So we are thinking, if it's in the future, maybe we can try file input map to represent the input. That means file map of each tile and using a CNN architecture to train this neural network. So that may be our future choices and suggestions for this subject. Finally, let's watch some small demos. In this game, player 0 is the MCTS agent, and player 1 is the neural network agent. We found that our neural network agent can not convert the performance not very well. And we can see this process that MCTS needs much more time to do the computation. And now let's see again between A star and to the BFS MCTS theory we mentioned before. Our BFS MCTS theory agent